Hello everyone again. So in this recording I will solve a simple problem. And the problem statement is that we have a car traveling with a velocity of 3t squared minus 6t in a horizontal path. To determine the distance traveled in 3.5 seconds, the average velocity and the average speed. As I said in the first lecture, that is, the problems sometimes will help us to gain the skills to solve the problems in dynamics, but the problems also sometimes will introduce new concepts because I will not talk about the theory due to time limitations, but I will mostly talk about the theory during the problem solution. So you will learn concepts while solving the problem. So in this problem, so we will just mention that the velocity is a vector quantity. So if you know it from physics. The acceleration is also a vector quantity, so it has direction and it has the magnitude. So if you just check this velocity here is given as v is 3t squared minus 6t, and I can write it as 3t 1 minus 2, sorry, t minus 2. And if I take t is less than 2, you can notice that this part is negative, this part is positive, and then velocity is negative. Let's say 0 to 2, because time cannot be less than 0. If I take the t is as greater than 2, and then velocity will become positive. So when the time is less than 2, the object travels to the left. Moves to the left. If it is greater than 2, the object moves to the right. But if I want to show it in a chart, say that this is the point O, the initial point. And then this is the 2 times 2. So the object starts here, moves here, and then here. As you can notice, when the time is less than 2, the object travels to the left, and then as the time grows more than 2, the object moves to the right. First, let's try to find the distance in 3.5 seconds, the average velocity, and the average speed. So as we said that the velocity is the change of position with respect to time. And in this case, so we can write it as this way. Okay. We just separate and then integrate. We put the initial time as 0, and then the time is 0, and then we will have the time as t. Similarly here, we will have the position as 0 and then position as s. Now let's replace the v value here. So it will be that 3t squared minus 6t from 0 to time t and then dt, and then from 0 to s and time ds. When time is 0, the distance is 0. When time is t, distance is s. These are just arbitrary variables. You can put anything you want. So we are saying that from 0 to any value. That's what it means. So if you integrate it, so the first one will be t to the power of 3. And then second one will be that. Let me write in full form. First one will be 3 times t to the power of 3 divided by 3 minus 6 times t to the power of 2 minus by 2. So this one is from 0 to t, and that will be equal to s minus 0. So cancel out, and then 3 here. So it will be that t to the power of 3 minus 3t squared, and that's s. This is the change of position with respect to time. And then we come back here. So I will just put it here. And then let's first start the times 2. When you replace the times 2, s when the times 2, it will be 8 minus 4, 3, 12, and then negative 4. So it moves to the left with a distance of 4. Okay. I did not specify the unit. It can be the feet, the miles, meters, whatever. And it will travel the same distance here as well. It will be 4. And then we can find how much it traveled, the s, and times 3.5. Okay, so let me just show you. So it will be that 48.7. So 48.875 minus then 3 times 36, and that will be equal to and then 6.125. Okay, that is the total distance that is covered by this car. Then if I add it here, and then this part will be 6.125 meter, and then I will not specify the unit here. And then here times 3.5. So we are calculating here the times 0. So we are calculating the variables with respect to the initial position. So the object traveled 4 meters, and then 4 meters, and 6.125 meters. Okay, so the distance traveled, the total distance, will be that 4 plus 4 plus 6.125, 14.125. And then the average velocity will be that velocity average. The displacement. Displacement is the final position minus the initial position. So it will be that this will be the displacement and divided by the time. And time is that 3.5 seconds. And then it will be 1.75. Let's say that units are meters per second, or ft per second. The units are not given, so these are arbitrary. And then the average speed will be that the total distance and then divided by the time. The total distance is 14.125, and then time is 3.5, and then it will be equal to 4.5 4.04 meters per second. Okay, that's the result.